Hello, in this lesson, we're going to talk about the proof of identities. In the homework set, I have given you two sets of identities that are to be proved. There are certainly many more, and I hope that if you find these not enough for your practice, just go find any textbook of pre-calculus or trigonometry. You should get plenty. And after all, all these identities I found, they are from some textbooks of trig textbooks or pre-calculus textbooks. In general, there are three formats about proving identity. Okay, there's three formats. Okay, so for a given identity, which is to be proved, okay, for a given identity, we have a left-hand side, we have a right-hand side. One format is start from left, and then we go through steps, right? We go through steps, we get to go to multiple steps. Well, sometimes it's less than that, right? We go through steps and we ended up on right. So this is one format. Okay, so the first one, that's the first format. The second format, is starting from right. Starting from right. Okay, so the second format is starting from right and ended up on the left. This is the second format. The third one is that we start from the left and we ended up at a third place. So we ended up at a third place, say omega. Okay, and then we can say we don't have to start from left or right. We can from either side, right? So from left, we get to a third place. And from the right, we also get to the same place. Okay, so from right, we also get to the same place. And since omega is the same as omega, so then it's proved, okay? In any identity proof, when the identity is given, ask us to prove, okay? Usually the wording goes like this, proof, right? I'm gonna take the first example in our homework. Ask us to prove that sine theta divided by tangent theta is equals to cosine theta. Cosine theta, right? When we are given something like this, okay, we're working on this proof, provided we don't know it is true or not. Okay, so when we are proving, okay, the underlying assumption is that we need to pretend that this is not, we don't know it's true or not. The underlying assumption is that we don't know it is true yet. Okay, for this reason, don't do this. Okay, so we start with what not to do. Okay, because I see a lot of people doing this. Okay, so I see this a lot from my past teaching experience, right? the student start to prove, and then the student would do this. The student would do, okay, sine x, right? Sine theta, and tangent theta equals to sine theta over sine theta over cosine theta. Okay, and that equals to cosine theta. Okay, and then the student will continue to say, all right, so the next one, so let me make it larger, okay? And the next one, the student will go, okay, you're gonna do whatever, right? So the left-hand side, so you're gonna multiply cosine theta on the top and multiply cosine theta in the bottom. For example, suppose this is what you do, right? Okay, and then the student will end up with sine theta multiply cosine theta. Okay, and in the denominator, it's just sine theta, because this is cosine theta and this cosine theta will be reduced. So we left with sine theta. And so the student will continue to write like this. Okay. And in the end, we get, the student will write cosine theta equals to cosine theta. I saw this kind of proof a lot, so many times. So what is wrong with it, right? I'm telling you, don't do this. You can do this on the scratch paper, maybe, but don't do it when you present your work to a professor, okay? Don't do this when you present this to a teacher, because this is how we're gonna read it. We're gonna read it, the first line, you're telling the reader, this is true. And then you say, oh, from this is true, therefore this is true. From this true, and the next one is true. And cosine theta is the same as cosine theta. So you start with assuming this is true. Okay, so by starting to write this way, you have assumed it is true already. So you have assumed it is true already. Remember, when we are to prove something, we don't know it's true yet. So you cannot start with it. You cannot start with it. So please do not prove it this way. So how should we show your, how should you show your work to get your credit, right? At least for someone like me, I would say, okay, this is right. So what will be the right, in my opinion? Okay, what will be the right in my opinion? And you could also look at the textbook, any particular textbook, to see how proof is done. Okay, so conventionally, mathematically, first of all, don't do this. Don't start telling the reader, because that's what you're telling the reader. Okay, you're telling the reader what is to be proved is true. But we ask you to prove it. We ask you to prove it's true. So you need to pretend at least that this is not true yet. Okay, excuse me. So this is how you should show work. So I'm going to use this simple example to show how to show work. Okay, so here's my proof. Okay, here's my proof. I will start with the left. You can start with the right too, if you wish. Okay, I'll start with the left. Okay, we seem to be most natural in this case, right? And then I will say the left is sine theta over tangent theta, and sine theta over tangent theta can be replaced by sine theta over cosine theta. Cosine theta. Okay, and then we're going to multiply by 1. Multiply by 1. So we take the whole thing and multiply by 1. Okay, so how do we multiply by 1? We multiply the common denominator. which is a cosine theta on the top, and will multiply cosine theta in the bottom. So in effect, we're multiplying by 1. Anything times 1 stay the same. So in this statement, right, you reader usually understand these. You don't have to point it out, but I point it out just to emphasize, right? You start from the left, every step of the way, you have a reason for that. You have a reason to justify your equal sign. Every equal sign has to be justified. Okay, so from this equals from here to the next equal sign, I'm replacing tangent theta by its equal. And from here to the next step, and I'm multiplying both top and bottom by the same quantity. So I'm multiplying by 1. And we know that anything times 1 stay the same. Any number times 1 is the same as the number, right? Any number times 1 stay the same. And then we're going to reduce it, right? We reduce it, so cosine theta in the denominator multiply cosine theta on the top, so the denominator will be left with just sine theta, right? And the next step, you just reduce it. So what we do is that we use this simple example just to demonstrate, okay, to demonstrate how to show your work, in order to get those points you want. So in the end, we get cosine theta. And cosine theta is on the right. Cosine theta is on the right. So this is the first format I'm talking about. This is the first format I'm talking about. So pretend this is not, we don't know it's true or not, but we just know we need to demonstrate that from left, we can end up on the right. So that's what we do, okay? Of course, you can do it from right to left. You can certainly do it from right to left, right? So then you say, then you have, usually you have a conclusion. Then you say, thus, or therefore, right? This is true, okay? Now, let's look at the second format. Let's look at the second format. What if I do it from the second format, right? From right to left, okay? So for the same question, I'm just going to use a different format. Why format is so important? The format reflects your, whether you understand the underlying assumption, which is, this is a to be proved. It is not true yet until you proved it, okay? So suppose I do it from right, okay? So now I know from what I know, I have the right-hand side, right? You don't have to show every way to do it, but suppose I want to show it from right to left. How do I get there? How do I get there? Okay. Remember, this is the situation that we start from right, and we know where we're going. We know where we are going. Okay, we know where we are going. So what I would do is that I'm going to move in that direction. I'm going to move in that direction. So I'm going to do sine theta divided by sine theta. So I multiply by 1 to cosine theta. You see, I'm moving towards that direction. Okay. And the next step, right? I got sine theta multiply cosine theta. Oops. I have sine theta multiply cosine theta divided by sine theta. And I know the direction I'm going. I know where I'm heading. So I'm going to divide the top and the bottom by cosine theta. Okay. Okay. So I'm dividing the top and dividing the bottom by the same quantity, cosine theta. And this is a cosine theta. Okay, so this example, you can see we start from right, and then what do we get next? What do we get next? In the denominator, I already get my tangent theta. I got my tangent theta already. And what's on the top? The top is a cosine theta and cosine theta. These are reduced, so I have sine theta. So this is how you see we end up on the left. We start from right, we ended up on the left. Then we can say, thus, this is true. So you can see we pretend it is true. It is, we don't know. Pretend we don't know, right? But we know where we are heading, basically. Okay. The third format we do from here. Okay, the third format. We're still proving this guy. We're still proving this guy. Okay, but this time I'm going to use the third format, right? So far you can see I've shown you, you either start from left to right, you ended up on the right, and then you proved it. Or you start from right, you ended up on the left, and you have proved it too. And the third one is that you start from left, you ended somewhere, you ended up somewhere, or you start from right, you ended up at the same place. And because these two are the same, therefore left is the same as right. You can see there's a logical reasoning behind what you present, what we present. Okay, so now we're going to try the third format. Okay, so we're going to try the first format. So this is our third format. Okay, so I basically, you don't need to say from, right? So my left, this is my left. Okay, this is my left. For my left, I'm going to just continue the process, right? I have sine theta over sine theta over cosine theta, right? I just replace tangent theta by its equal, which is sine theta over cosine theta. So then I'm going to multiply cosine theta, and then I'm going to multiply cosine theta here. So I'm multiplying by 1, right? Anything times 1 stay the same, right? So the next one, the next step, let's see what's the omega. Once we done that, the top will be sine theta, cosine theta. The bottom, cosine theta and cosine theta reduced, we have sine theta. And the right-hand side, I have a cosine theta to start with. Okay, so that's my right-hand side. Okay, so I have a cosine theta. So what I would do is I'm going to take this cosine theta and I'm going to multiply sine theta over sine theta. I'm multiplying by 1 again. And we ended up, where do we end up? We end up at the same place. You see, numerator times numerator, right? Cosine theta times sine theta is sine theta times cosine theta divided by sine theta. So we ended up on the third place, the omega, the place of omega. Okay. So this is the third format. Almost every proof can be done by all 3 formats, but we don't ask you to do every format. We just want you to do one of the 3 formats. Left to right, right to left actually can be viewed as one format. And the third format, you know, we find the third place, which are the same, right? So then you can say thus. You can say thus. Left is same as right. So left ended up here and right ended up at the same place, and therefore left is same as right. So this is the important part about how to show work logically, and the rest is just practice. The rest is a practice. Okay, for example, let us look at what when you do these proof, of course, it's all starting from definition: sine, cosine, tangent, cotangent, secant, cosecant. All these relationship has been spelled out by definition. So let's prove a few more. So I'm going to choose one from the homework. Okay, you see number 5. Number 5 actually is something we actually did before. We actually did this before. Okay, we did it, but we're gonna do it at this time. So let's see how we're gonna do this. Okay, how we're gonna do this. There are usually more than one way to prove one identity, and once again, three format. And typically when you show your work to your teacher, and this is after you have carefully gone through the logical relationship, and logically you think about these, how to present your work in one of the 3 formats. Do not turn in your scratch paper work. Please leave your scratch paper work on the scratch paper. Okay, when you present your work, it has to be logical. Once again, we pretend we don't know it is true, and we're going to show it is true. So you cannot start from this. Okay, so let's prove this. Okay, when proving this, certainly we will definitely have trial and errors. For example, before I prove, I probably put something on my scratch paper. I have something on my scratch paper because I'm thinking, how am I going to prove this? Should I start from left or should I start from the right? Okay, so before you prove it, you have a piece of paper. This is my scratch paper. Okay, this is my scratch paper. So I'm going to try to see how I'm going to do it. And one thing is that I can start from the right? When starting from right, and I certainly would see that is 1/8. Okay, so I'm going to slightly change the way I'm writing it. Okay, and then I'm thinking, well, on the right side, I have 4 times x. On the left-hand side, I have sine square x, cosine square x. So maybe there's something I can reduce. Yes. So from that, and certainly it's worth our effort to just write it down the scratch. So I'm showing you this as my scratch paper, but I need to somewhat, get organized. So cosine 4x, all right? So I have 1 minus cosine 4x. So I'm going to see cosine 4x as 2 times 2x. 2 times 2x. Because I know the double angle. I know a double angle, right? Cosine 2x. Let's see, I'm going to write this formula. Okay, cosine 2 omega is equals to, there's 3 formula, right? There's 3 formula. So I'm going to put that in my note. Even though this is scratch paper, I still want to keep it somewhat organized, especially I'm doing this in front of you, right? So my thinking is that which one do I use, right? Which one do I use? Do I use cosine squared of omega multiply sine square of omega? Could I try this? Of course I can. Right? Of course I can. So in that case, my cosine 2 times omega. So my 2x is omega, right? You can see cosine 2 times omega. Do you see that? okay? So this is a double angle for cosine double angle, okay? So I see 4x as 2 times 2x. So my omega is 2x. So my omega is 2x, okay? So that will be replaced by omega, and that will be replaced by omega. Okay, so I'm going to replace this piece by its equal, All right? So on my next step, I will replace this piece by its equal. And I need to insert a parentheses here. I need to insert a parentheses because I'm replacing this piece by its equal, right? And there's a negative sign in front of it, and the replacement has a something subtract something else. So I want to make sure it's subtracting the whole thing, If you want to make some adjustment about the parentheses and brackets, you certainly can. For example, here I can use a bracket, right? If I had to use a bracket before, like last time, then I can use parentheses this time. All of these symbol, parentheses, brackets doesn't matter, even though conventionally we use parentheses first, and the next layer is a bracket, and then it's a curly brackets. You just want to make sure these parentheses and brackets help us to clearly specify the order of operation. So we get to this point. We have used double angle formula. Right? So this time I'm going to do 1 minus. So I'm going to apply the negative sign inside. So I'm going to have, so this is going to be plus. Okay, this is going to be plus. And then what? 1 minus cosine squared 2x. Remember, we're going from right to left. How can we get closer to it? How do we get closer to it? On the right-hand side, there's no more double angle, right? There's no more double angle. So what do we do? What do we do? Well, you may think of using the double angle one more time, right? So I'm going to take that piece, our previous formula, right? 2 times omega, right? So this is omega. This is omega. Whoops. Sorry about that. Okay, so that is my omega. Here we go, right? So once we have that, maybe we can use this formula one more time. In other words, cosine square of 2x, cosine square 2x. What is this notation? Well, we know that this is a cosine 2x being squared, right? And this piece is the same thing, right? The sine, and that's squared. We're on scratch paper, right? So we can be experimenting, freely. Okay, of course, you still need to use the formula. So now for cosine 2x, what do we get? This time, cosine 2x, omega is going to be x, right? So I'm going to apply this formula, and this is a 2x. Oops, this is a square. I'm sorry. This is a cosine square. Okay, so this is a cosine square. So this is a cosine square x, and this is a sine square x. So for this piece, I can replace it by its equal. Right? So that's what I'm going to do. So this piece, okay, subtracting it, right? So this piece will be replaced by its equal, which is right here. You see, I still inserted that parentheses because this is subtracting that, right? And there's a square outside. Be careful, there's a square outside. Okay, because we just replace the cosine 2x by it, and there's a cosine square 2x, right? So there's a square outside. How about this piece? How about this piece? How about this piece? We pretty much know what to do with that piece, right? We're gonna do the FOIL. We're gonna do the FOIL. How about this piece? Sine 2x. What is sine 2x? What is sine double angle? Sine 2x is equal to 2 times sine x, sine x, right? That's a sine double angle. So this piece will be replaced by its equal as well, which is here. Right there. Right there. Okay. So now we got all these squares. What are we going to do? Well, we just have to do FOIL. We just have to do FOIL. So let's see how we're going to do the FOIL. Okay. All of these in the bracket, all these things in the bracket, and we're going to square this piece. Okay. So how do we square this piece? Let's expand our scratch paper, right? You can think of this as A minus B squared. What is A minus B squared? It's A squared. It's A minus B times A minus B. So it's A squared minus 2AB plus B squared. Right? Okay. And then what? And then what? Well, we got our cosine square x. Right? We got our cosine square x. And we got our sine square x. Right? So that's our A. This is A. Okay, so this piece is going to be A. So this is and A is a cosine square x. So everywhere A will be replaced by cosine square x. B is sine square x. So everywhere B will be replaced by sine square x. So B by sine square x. Okay. All right. Do you follow me? All right. If you do follow me, this is the time we can just organize it, adjust a little bit. Okay. Because this piece will give us a cosine squared x, then squared, that's going to give us a cosine to the power of 4x minus 2 times cosine square x times sine square x. Okay, so we got that. Okay, plus sine to the power of 4x. Okay, don't forget, we're just experimenting on scratch paper. Okay, but we still want to write it reasonably well so we can follow ourselves. So now it's time to plug in. Okay, so I'm going to replace this piece by its equal, which is right here. Okay, so this entire piece will be replaced. Obviously, I need a parentheses, so I'm going to replace it by its equal. And this piece, when we square every term, so we're going to get 2 squared, sine squared, cosine squared. Okay, so 2 squared is 4. And sine squared and cosine squared. Now be careful. Okay. We got to open up the parentheses. So we can open up this parentheses for sure. Okay. I wish this is a classroom that you can interact with me, because no one is watching for me whether I made a mistake or not. Okay. All right, so I'm gonna open up the parentheses inside. So what I get is that this is gonna be negative, this is gonna be positive, this is gonna be negative. Okay, so this is a negative, this is a positive. And I'm gonna remove the parentheses. Let's see, can we reduce something? It looks like we can, right? So this is like a 4, this looks like a 2, this is 2 times that, and this is a 4 times that, so we get a 6 of it, 6 times of it. Where are we going, right? So you just wonder, is this going to work? Is this going to work? Okay, is this going to work? All right. At this point, I'm wondering where I'm going. I'm wondering where I am going. Did I make any mistake somewhere? Right? Did I make any mistake somewhere? This is very common. This is a common. And then can we reduce it anything? Can we reduce anything? If there could be anything is there anything I could do differently? Well, as I look back, when I was doing this, I did think of something else, right? So now I'm going back and I thought, okay, maybe I can do something here. You see, this is something you can do on the scratch paper, right? So if I do it here, say I'm gonna apply the sign to the inside. So I'm gonna open the parentheses. So this is gonna be plus 1 minus sine cosine squared 2x. What would that be equal to? What does that equal to? What does that equal to? You know, at the time I thought about doing that, but and then I thought about doing this as well. So I going back and forth. Okay, so let's try this first, right? Remember, we have this identity. We have this identity. Cosine squared omega plus cosine squared omega equals to 1. This is true always, right? So as a result, sine square of omega is equals to 1 minus cosine square omega. Do you guys see what I'm doing here? When I get to this place, then I feel lost. I did feel lost, and I realized, hey, maybe I can just go back somewhere to take a different route. That's what I'm doing. So what is being shown to you is that trial and error is part of doing mathematics. Trial and error is part of doing mathematics. Okay, very few people will get it right the first time, especially for complicated questions. So don't feel bad and don't get frustrated. It just keep going and try. If this way doesn't work, try something else. Okay. So by this time I realized, you know what? I can do 1 minus cosine squared 2x, because the 2x can be totally my what? 2x is my omega. So this is my omega. If this is omega, that works. So sine squared 2x equals to 1 minus cosine squared 2x. You see? So this piece now can be replaced by its equal. Okay, so this piece will be replaced by its equal, which is sine squared 2x. This looks more promising. Then what you do, you probably just tore up, right? Just tore up and throw that in the trash. And throw that in the trash, right? That's what scratch paper is for. That's what scratch paper is for, because I realized, you know what? I'm going to get there. I'm going to get there. Okay. Now it's very promising. I have two of these. And then I'm going to write it down that way. So that's 1/8. Okay. And multiply 2 times sine square of 2x. And 2 and 1/8 will reduce. So we're getting the following. Okay, we're getting 1/4, right? And then what is sine 2x? What is sine 2x? Right? Because this piece is the same as sine x to the power 2. Right? So I can use that. The other identity that we have done, the sine double angle. So sine 2x, sine 2x equals to 2 times sine x cosine x. So I'm going to replace sine 2x by its equal. So that's on my next step. Okay, so I'm going to replace sine 2x by its equal. There, right? And what do we get? Well, we get 1/4, and everything inside the parentheses get to be squared, right? And 2 squared is 4. And then we get sine squared of x and cosine squared of x. And we're so close to the left. And we finally reached the left. We have reached the left. So this is the left. Okay, this is the left. Okay, trial and error, patience. Okay, that's what it takes you where you need to be. Okay, we all go through that process, including myself and a lot of other people I know. So we already got the proof. Right? So we can use this piece to write down our proof. Okay, so this version is going to be from right to left. So I'm going to write down the formal proof. So you're going to start with the right. Okay, so I'm going to take all of these. Okay, I'm going to take all of these. Okay, maybe doing some trimming. So I'm going to show my professor my work. So next I'm going to show you how to show your work, right? So you're going to always tell the reader, you start from right. You're telling the reader, I'm starting from the right. Okay, starting from the right. This step is actually optional, so I just trim it, right? I can start from this side. So I need this piece, and I did this piece, and so I opened up the parentheses. So I got these. So all of these steps are what I need. And I can put it on the side to tell my reader, so hey, look, this is what I used. But you need to make sure that is very clear for your reader to know. Okay, that's very clear for your reader to know. So typically, if you have a piece of paper, if you write this on a piece of paper or you write it electronically, you're going to divide this piece of paper. Right? This is a piece of paper. Okay, and you divide this piece of paper into two pieces. Okay, if you like to tell the reader what formula have you have used, that you can put it on the side. Okay, you can put it on the side. Does that make sense? The bottom line is you want to show your work to the best of your ability for the reader to see what you're trying to do. So here I'm using one of the two formats, okay? But anyway, so now we have proved it, therefore we can tell the reader, you know what, I have proved it. I gone from right to left. Then you can say thus, so that's the conclusion, We did it, we have done this question actually from another setting. I don't know if you guys remember, I had a lesson which is reduce the power. We could do it from left to right. Okay, so another way I like to show you here. Okay, some of you have seen that. If you saw that other proof, it's great. Otherwise, I'm going to show you here is because these two formula are going to be very, very useful as well. Okay, so once again, we're going to prove it. We're going to prove this piece, but I'm going to do it from left to right. I'm going to do it from left, right. Okay. From left to right, we have these two formula. Okay, the double angle formula. One is sine square of x. Okay, it equals to 1 minus cosine 2x over 2. I hope you remember by this time, cosine square of x equals to half of 1 plus cosine 2x, right? We proved it. We proved this at the proving proving formula diagram, okay, in those sections, in those lessons. So from the left, okay, you still start from left, you tell the reader, you quote the formula, and then you start from one side. So here I'm starting from left. So what I have here is that I have this piece, right? And I plug in this piece there, okay? And then I know where I'm going. Yes, I do, right? I'm starting from left. I'm going towards that direction to the right. So now I get a quarter, okay? And I got two parentheses, 1 minus cosine 2x. And the other piece is 1 plus cosine 2x. Okay, and then what? And then we got 1/4 a minus b times a plus b. This is another very commonly used algebraic formula. Okay, so a minus b times a plus b. So that formula, this product reminded me of this formula, the product, and that equals to a squared minus b squared. Okay, so the next step, we're going to have 1 squared minus cosine 2x squared. There. Okay, and of course you could have write it just like this. And 1 squared is 1, and cosine 2x squared is shorthand written like this. But we're still not on the right hand side yet, right? We're still not there yet. So what do we do? What do we do? And this must be related to some double angle formula, right? It must be related to some double angle formula. So how do we get there? How do we get there, right? So we need a cosine 4x. So how is a cosine 4x related to the formula? I think this formula might give us some insight, isn't it? This formula might give us some insight, isn't it? All right. This is a cosine square 2x. This is a cosine. You can see the relationship is a double angle. So this is x, this is 2x. So if this is 2x, and this is going to be 4x. Okay. That's how they're related. That's how they're related, double angle. Now, we're going to replace this piece by its equal. There. We got our cosine 4x finally, but it's still not in that form yet. Okay, so we need to do some algebraic manipulation. We're going to do some algebraic manipulation, which is to say finding common denominator. So 1 is 2 over 2, right? 2 over 2. And then what? We got the same denominator, right? So we're going to do 2 minus 1 minus cosine 4x. So we're going to do 2 minus 1 minus cosine 4x. So this piece is gone. Are we there yet? I think we're pretty close to it, isn't it? Oh, this is 1, sorry. This is 1, right? 2 minus 1. So this piece is 1. Are we there yet? Are we there yet? Are we there yet? Yes, we're very close. All we have to do is take the 4 times 2. Okay, so we get to the right. You see, proving identity, the only good thing, one of the best part about it is that you know where you're going. You know where you're going. Okay, so you have a target. You just don't know. You just need to build a bridge to demonstrate that, oh, excuse me, the left is the same as right. So it's proved. It's proved. Okay. So this is the second proof. And this is, of course, you're going to wrap it up. You're going to tell the reader, because you're telling the reader, when you're writing down the proof, you are basically guiding your reader through the steps. You justify every step so the reader can understand what you're doing and following your step. And you tell the reader, look, this is the same as right. Then you say, thus, proved. This is proved. Okay, because you are demonstrating to the reader that you have demonstrated this is true with your well-written steps, step by step, logically presented to your reader. Okay. All right, so that proof seemed to be pretty straightforward, right? But once we get to it, sometimes it takes it takes some effort. So when we do the, when we scratch on the scratch paper about how to go about to prove it, you want to make sure that you want to pick the method you like. You don't have to show every way. But of course, the more way you know, the better. But your work has to be very, very logical, has to be very, very logical. And once again, pretend. You don't know it's true, right? So you start from one side. That's why you start from one side. Never, ever start on both sides. Okay, never, ever start on both sides. When I see that, it just bothers me because it just, for me, there's no logic. You don't know what's to be proved. If you know what is to be proved, then you certainly should not start with that as the fact to go by, as we indicated at the beginning. Some of these identities I've chosen, certainly I have some intention, okay? For example, number 7. Right, number 7 on your homework, proving identity. So here you can see you have a cosine of negative x minus sine of negative x. equals to cosine x plus sine x. This identity seems to be rather straightforward, okay? It's rather straightforward. However, this identity is for us to apply the even function and odd function property, okay? So let's prove it. Let's prove it. Naturally, we're going to start from the left. Of course, you can start from the right, okay? So when we start from the left, I would use the even function, odd function property. Okay, cosine is even function, so it's opposite input give the same output. So the next one, sine of negative x is negative sine x, that's the odd function, right? So as a result, you get equals to cosine x plus sine x, and that's equals to right, and that equals to right. Now you're done, okay? Now you say thus. You certainly can do it from right to left for sure. Okay, you can do it from right to left for sure. So I'm going to leave that for you. Number 9 is about even odd. Let's pick a couple questions on the right. Say number 6. Okay, number 6. We did number 7, so let's look at number 6. Number 6, we have tangent x. Oops. Tangent x equals to sine 2x divided by 1 plus cosine 2x. Okay. Typically, I'm not saying always. In many cases, when we prove, we tend to start from the side that is a little bit more complicated and moving towards the less complicated side. And that complicated side could be on either side, okay? So in this one, we probably would start with the right-hand side, okay? And here, since I'm not, well, even I'm not quite certain, right, how I'm going about this. So I would just put out my scratch paper. Okay, my scratch paper, I just start from the right-hand side. Okay, so as I'm starting on my right-hand side, I'm going to say, oh, you see the left-hand side has no double angle. So I'm going to reduce the double angle, right? So it's natural, we're going to do it that way. So 2 times sine x cosine x, the bottom is 1 plus, okay, 1 plus cosine 2x. Cosine 2x, we have 3 formulas. So which one do we use? Okay, which one do we use? You know what? I'm going to use that formula, which is 2 times cosine squared x minus 1. And this way, 1 minus 1 is gone, right? So we take away the 1. So in the next step, I no longer have the constants there, right? These are gone. Oh, 2 are gone. And wait a second, it looks like this is going to be an easy proof, right? Because the cosine squared, the top is a cosine times sine. So one of the cosine, take away the cosine there. And here we go. We got a tangent already. Yay. So that's the left-hand side. That's the left-hand side. Okay, so at this point, and I realized, oh, you know what? I'm just going to turn this into a proof. Okay, start from right and ended up on the left and done. And then you say thus, right? And this is true. This is true. Okay, this is true. I think for this lesson, it's about an hour already. Okay, so maybe I will do another lesson for identity proof. We're gonna do set B. Okay, maybe 1 or 2 questions from set A. I will see you on the next lesson. Thank you for watching.